Okay, next theorem is theorem number 2. If F is analytic at Z0 and F dash of Z0 not equal to 0, then there is an open disk. Then there is an open disk D connected at Z0 such that F is 1 to 1 on D. Okay, listen here. If a function is analytic, its derivative not equal to 0, that we know. Then the open disk D, open disk, the term used in a complex number. Okay, open disk D is connected at Z0. F is analytic at Z0 and open disk D is connected at Z0 such that F is 1 to 1. The relation is 1 to 1. So we can start the proof. Whatever they give, we write it first. Since F is analytic, F dash is also analytic. And mod F dash of Z not greater than 0. The reason, this is a theorem, there is an open disk D centered at Z not such that centered at analytic at Z not, and this is connected at Z not. This connected point center at Z, because the distance between the derivative of the 2 points F dash of Z minus F dash of Z not is less than or equal to mod F dash of Z not by 2. Here, this is Cauchy's inequality we used here for all Z in D. So then we take 2 points in that one. F of Z1 minus F of Z2 is also is greater than or equal to mod Z1 minus Z2 into mod Z0 F dash of Z0 by 2. For Z1 comma Z2 inside the disk. Inside 2 points we take inside the disk. So F is 1 to 1 in D. Okay. Then let gamma be the segment joining Z1 and Z2. Then we have, okay, the point Z1 is Z0 is joining with the F and D, like that. The line segment, you joining the line segment Z1 and Z2 using the whole function gamma. Then we can write mod F of Z1 minus F of Z2. We again rearrange in the term used for gamma, integral over gamma F dash of Z. That is equal to, again we can rearrange this one, gamma F dash of Z naught dz minus this integral gamma F dash of Z naught minus F dash of Z into dz. Okay, we know that this is less than or equal to F dash of Z naught. That one, F dash of Z minus F dash of Z naught, like that. F dash of Z naught minus F dash of Z. We can write it this one, mod is greater than or equal to, mod f of z1 minus f of z2 is greater than or equal to mod f dash of z naught into z2 minus z1 minus this one we know that f dash of z naught mod by sorry by അല്ല by ഇവിടെ ഉപയോഗിച്ചല്ലോ okay you by that is mod z2 minus z1 that is the previous result. See this one, that is equal to, which is equivalent to full. Okay, this is the distance between this one, this is 1, the within effect 1 into half, 1 minus half, that means half mod f dash of z naught into z2 minus z1. Is it okay? Okay, this we can use here. Okay, the distance between the point z1 minus z2, that is on the points on open disk. So we can write it the half of the center of derivative, and its distance between image, the distance between image is equal to the half of the derivative and its distance between 2 points. Okay, this is the result. Okay, next one one of the small definition is what is open mapping theorem, okay, or open mapping property. That is very important, please don't forget that one, open mapping property. What is that one? Sometimes it is for used for uh, open mapping theorem. Like that we need to study the Raymond's mapping theorem. So here we used open mapping property. The definition is used in one of the theorem, and it will also ask in 2 marks question or 1 mark question. Okay, please remember that one, open mapping property. What is open mapping property? A function is open mapping if the image of every open set in its domain is itself open. Okay, that means the function of officer, like that, the function maps open sets to open sets. You know the terms open sets and closed set. For analytic functions we use on theorem. For analytic functions we can use on theorem. Okay, that is called open mapping theorem. We need only to study the open mapping property now. A function is open mapping if the image of every open set in its domain itself open, that is the function maps open set to open set. That means what is open mapping property? The function is open set to, function maps open set to open set. Okay, next theorem, the third theorem 3. any any analytic function that is non-constant on domain is an open mapping. What is open mapping? Open mapping is set to open set. Okay. So we F maths one of the simple theorem. Let F maps the domain D onto the open set O. Open set name O. To join W1 equal to F of Z. Imagine F of Z1 to W2 equal to F of Z2. By the polygon, any figure, okay, polygon path in O. Then join Z1 to Z2 in D. The image, then we get the image. Then the image of this path, Z1 to Z2 path. This path is a path joining W1 to W2 in O. Okay, Z1 to Z2 is on D and W1 to W1 to W2 is on O. Okay, but here it's not a polygon. Is also sometimes it is not a polygonal. Okay, so in here we can say that lying inside Z1 to Z2 is an open set on that domain only, like that W1 and W2 also open to that O. Here we can say that a path lying inside in this we can say that the path lying that, okay, what, but any component topologists can, some topologists prove that a path lying inside an open set. So hence O is connected. Hence O is connected. Open set is connected on itself only. Okay, once more. What is open mapping property? A function is open mapping if the image of every open set in its domain itself open. That is the function maps so open set to open set. But here like that, Z1 to Z2 is open on that D only domain, and like similarly W1 to W2 is also open in that O. Okay, thank you.